You have q squared plus 25 equals 0. Let's solve this by the squared property. We can look at a perfect square. We have q squared here. Remember that a perfect square is not always monomial. It could also be binomial. It's a square of a binomial. It's a square of a monomial. Here, your square is a monomial q squared. But there's a number outside. We need to get rid of that. So we must subtract both sides by 25. And we come up with q squared, 0 here, equals 0 minus 25, negative 25. And only then you can apply square root property. So we get the square root of both sides, positive, negative. What's the square root of q squared? Q. Well, we have positive, negative square root of 25. Well, that is not a perfect square, negative 25, right? But note that we can rewrite this as a complex number, right? So we can write it as positive, negative square root of 25 times negative 1, right? And of course, we have positive, negative square root of 25, square root of negative 1. What's square root of negative 1? You have positive, negative square root of 25, 5. Square root of negative 1 is your I. All right, it's an I. Remember from yesterday, if you were here yesterday, but if you missed it, you can rewrite square root of negative 1 as I. Remember that I is equal to square root of negative 1. So we have positive, negative 5I. So your solution set would be negative 5I and then 5I. That's our solution set. Now for future examples, if you have, say, the square root of negative 36, you can simply write this as, since this is square root of negative 36, you just get the square of 36. The square of 36, 6, but you have to put I. All right, the solution is like this. That's the expanded solution, and this is the complete solution why it's 5I. So that when you have, say, square of negative 25, simply get the square of 25, which is 5, and then I. If you want to show your complete solution why it's I, then you have to do this. You factor negative 25, you have 25, negative 1. Use the properties of a square root. You can rewrite square root 25 times negative 1 as square root 25 times square root of negative 1. Then square root of 25 is 5. Square root of negative 1 is it can be written as 5. So now you have this. Now let me ask you, what is square root of negative 49 using complex number? Square root of 49 is 7. You have the square root of negative 1 there, which is I. So 7I. Okay. You have 9n squared plus 64 equals 0. Do we have a perfect square here? 9 is a perfect square. N squared is a perfect square. 64. Well, we can, although this is a perfect square, but we need to isolate this 9n squared, right? And so we need to get rid of the constant, negative 64. Okay, minus 64, minus 64. We have now 9n squared. 64 minus 64 is 0. 0 minus 64, negative 64. Can we apply square root now? Yeah, 9n squared is a perfect square. So we can apply the square root property here. Let's get the square root. Square root of 9 here, 3. Square root of n squared, n, so 3n. And then you have a positive, right? Positive, negative. Square root of 64. 8, but that's negative, so we have to put I, positive, negative, I, 8I. I've shown how we come up with this in the previous examples, but in here, I believe you know why it's now 8I. All right. I hope you understand why it's 8I. Divide both sides by 3. You have n equals positive, negative 8 over 3I. So our solution set would be the set negative 8 over 3I and 8 over 3I. It's a complex number. This also means that there are no real roots because the roots are imaginary numbers. It's a complex number, right? Negative 8 over 3I and 8 over 3 are not real numbers. And so we can say there are no real roots. But if we say there are no real roots, specifically, what are these roots? We have negative 8 over 3I and 8 over 3I. These are not real roots. They are imaginary roots.